Welcome to Brain Vision.
In our case, we have a steel rod which is fixed in between two plates. Now, the temperature changes from 25 degrees Celsius to minus 25 degrees Celsius. And we want to find out the tensile stress. We know that stress, which is force by area, is strain times elastic coefficient, which is, and we know that strain is delta L by L times E. So we know that delta L is alpha delta T, giving us alpha delta T times elastic coefficient, which is in our case 12 into 10 power minus 6 is the alpha. Delta T is 50 degrees Celsius, obviously, times elastic coefficient of steel is 200 into 10 power 9, giving us 1.2 into 10 power 8 Newton per meter square. Now, we want to see if this will break our system. For that, we need to know the maximum tensile strength of steel. We can look this up in any book, and it turns out that the value of maximum tensile strength is 5 into 10 power 8 Newton per meter square for steel, which means because this number is smaller, the steel will not break. For part C, though, we consider a concrete rod for which alpha delta T E would be, alpha would be the same, 12 into 10 power minus 6 times delta T is obviously 50, but our elastic coefficient is 20 into 10 power 9, which gives us 1.2 into 10 power 7 Newton per meter square, 10 times smaller tensile stress. But the ultimate tensile strength for concrete is only 2 into 10 power 6 Newton per meter square, which means in this case, the system will break.